4.2 is finding the areas of triangles. And as we work in this chapter or in this section, again, I want you to keep in mind this kind of key purpose that you can derive or come up with the formula for finding the area of triangles. So it's not something that you need to memorize necessarily. I know that does help some of you and you will kind of commit it to memory, but you can figure out or derive that formula once you get to know a little bit about triangles and what relationship they have to some of these other polygons that we've been studying. The area of a triangle, as we figured out when we looked at the activity for 4.2, is since triangles are half of a rectangle, even when they are standing alone and you don't see the other half of them, we know if we were to duplicate an exact same triangle and then put it next to that original triangle, we would create a rectangle. So we use the formula 1/2 the product, which again we know means multiplication, of its base and its height. For the formula, when we write it out, we write area with a capital A, and again, that's helpful to know that we're talking about of a triangle. And it's equal to the base times the height, but we remember that we would have to split that base times the height, because that would be the rectangle, in half. So we write it as 1/2 times the base times the height. And that's the most common way to write it. Just to be fair, sometimes you will see it written as the area of a triangle is equal to the base times the height all together divided by 2. That one's not quite as common, but again, you get the same thing when you multiply 1/2 times something as you do when you divide by 2. These two actually mean the same thing. So it's fair just to see it both ways, and maybe one of them will stick for you a little bit better than the other one. One final thing to think about as you're getting to know this formula is that when we look at the triangle, it's a little hard sometimes to determine which is the base, because any of the three sides could technically be considered the base, but whichever way you decide to look at the triangle or turn it, then what you will need to keep in mind is that the height would have to be perpendicular, so it would have to go from one of the corners and it would have to go straight across and be able to form a right angle. So in this case, I would consider the base this particular side of the triangle, and then the height would be right here, kind of like what we did in parallelograms from time to time, where you would have to kind of draw it in yourself. But again, it would have to be going from one corner, and then it would have to be straight across, and it would have to form a right angle. For example 1, we're going to find the area of this particular triangle, and you can see here that we do have a right triangle because it has one right angle in here, and so it makes it a little bit easier because the base is kind of sitting flat, so it's okay to use that number, and then the height would be the one that is creating that right angle to the base, so that would be this number right here. That means we're not using anything from this side of the triangle over here. We don't have a measurement, and we don't need to use that for our formula. But we do keep in mind that our formula for this is area of a triangle is equal to 1/2 the base times the height. And when we go to fill that in, we're going to keep that 1/2 there for now, and then the base is right here, so that's 5 inches. We're going to substitute that in there, and then the height is right here, that's 8 inches, and then, oops, I almost put inches, but I don't need to do that. And then we're going to see there are a couple of ways that you could tackle this. When we go to multiply, it's pretty easy for us to just want to start at the left and kind of work to the right. The problem we're going to run into here is that 1/2 of 5, while it's not that hard of a number, you're going to find yourself in the world of fractions or decimals, because 1/2 of 5 would either be 2.5 or 2.5. So to make our lives a little bit easier, we're going to keep this tip or hint in mind from our last chapter, that you can use the associative property of multiplication, which says that we could regroup if we want to, and we can do the multiplying of the 5 times the 8 first, because 5 times 8 gives us 40. And then if we just take half of 40, you can think of that as, 1/2 times 40 if you want to do the fraction work, or you can just think of 40 as kind of being fraction over 1. And when you go to cross simplify and divide that by 2 and that by 2, then you know 40 divided by 2 is 20, and 2 divided by 2 is 1. And if I bump that up because I'm running out of space here, then you could think of this as 1 over 1 times 20 over 1, which is the same thing as 20, or 20 over 1. So that's one way to do it. Or you use your common sense math, which says half of 40 is 20, and that makes it even easier. We are going to continue to remember that all area, no matter what polygon we use, is going to need a label of square inches. So our final answer here would be 20 inches squared. As you work out these on your own problems, remember to keep in mind that the triangle is going to be only half of the base times height. That's the one that commonly gets forgotten. So if you use the formula every time, fill it in as area equals 1/2 times base times height, and then work from there. You should be all set. For this first on your own answer, again, I want to demonstrate how you can use those properties. So we know we're going to use the formula area equals 1/2 base times height. And in this case, the base was 11 and the height was 4. And again, last time we took half of 11, or we decided taking half of 11, or that first number would have gotten us a fraction or a decimal. So instead we regrouped and we focused on just multiplying those numbers together over here. So we're going to keep the half out of it and then do 11 times 4, which is 44. And then half of 44 would be equal to 22, which you could do the side math for to figure out. And that one is labeled as feet, so you'd need it as feet squared. But I'm very quickly going to show you just another way to think about this. If you start with your same formula, 1/2 base times height, and you fill in your base as 11 and your height as 4. Another property that we could do if we wanted to would be the commutative property. If you wanted to switch these two around, then you could do 1/2 times 4 times 11, and then half of 4 is a little bit easier to do mentally because half of 4 we know is 2, and then times 11, and then 2 times 11 is 22, and you can see that you get the same answer here doing it this way as you did the other way. So because of those properties, if it makes it easier to take half of just one of the numbers, then you can. But notice what we did not do is we did not take half of both numbers in this case. We took half of the base or the height, and then we multiplied it. And again, if that doesn't work for you, stick with the original way that we talked about. On this one again, I'm just going to demonstrate a different way to think, same steps, but just knowing that we can put things in different orders, make our lives a little bit easier. Filled in the 1/2 base times height, the base being 22, the height being 10. This time, if I multiply those two numbers together, again, it's totally fine, but 22 times 10 gives me a big number, 220. I'm going to choose to take half of the 22 this time, because half of 22 is 11, and then multiply it by the height, because I know that 11 times 10 is equal to 110, and it was meters this time, so I need square meters. But again, you could have just as easily done that by doing your original formula and then filling in your 22 and your 10, and then, whoops, out of space there. And then you could have done 22 times 10, which is 220, and then take half of that, which is 110. So again, I'm just trying to demonstrate a couple of different ways to think about this that would make it a little easier for you to do things mentally when possible. And once you find the way that makes the most sense to you, as long as it's working consistently, then you'll know it'll be fine because of those properties. For example 2, we're going to continue finding the area of a triangle, and this time they have one of those examples where the triangle does have a base that's kind of laying flat down right down here, but the height would be a little bit hard to find because it doesn't go corner to corner since this is an obtuse triangle. The angle is a wide angle, and so they demonstrate that if you still go from one corner down, that would have to be perpendicular, so it would have to make this right angle here, that you can still find the height even when it's not inside the triangle. Because if you can imagine this whole thing being on grid lines, that line would drop straight down here and it would still be equal in the number of spaces. So we still use the same formula, area equals 1/2 times base times height, and we fill in what we can. So the base in this case would be the 12, and the height, whoops, gotta finish that one. The height would be 9 meters. And again, just like we had before, if you need to use some of the properties to make it easier, you can. Or in this case, it might actually be easier just to start multiplying from the beginning. So 1/2 of 12 is 6. And notice I'm not really doing a lot of the fraction work. I'm not turning 12 into an improper fraction or anything like that. You can if you need to. But we know if we just say 1/2 of 12, we know that that's 6. So I'm trying to cut corners when we can, if it makes sense. If this were not a whole number that was easily cut in half, then you might want to consider some of your properties to move things around, or you might actually have to set that up as an improper fraction and multiply it to find your correct answer. But in this case, we can do 6, and then we can't cut the 9 in half, because if we're going to do it that way, we only can use the 1/2 one time, and then 6 times 9, when you multiply it together, gives you 54. And this one is labeled as meters, so we know we need to put meters squared or square meters as our final answer.